We describe arithmetic means as the terms between two terms of an arithmetic sequence. Now, similarly, geometric means are the terms between two terms in a geometric sequence. Let's have an example. Insert three geometric means between 5 and 3,125. Now, how many terms are to be considered if this is the given? So, if we want to insert three geometric means, we are considering 5 terms of the sequence. Let's see why. So, 5, the first, 3 spaces, and the last one. Therefore, we're considering 1, 2, 3, 4, 5 terms. Now, to fill the gaps, again, this is a geometric sequence because we need to insert geometric means. So, we want common ratio. So, to solve for the common ratio, we need to use the general formula for geometric sequence. Again, this is a sub n equals to a sub 1 times r raised to n minus 1. Now, let n is equals to 5. The question now is, sir, why 5? Because we're considering 1, 2, 3, 4, 5 terms in our sequence. So, n, the number of terms, is equals to 5. Let us substitute. We have a sub 5, n becomes 5. N becomes 5, so a sub 1 times r raised to 5 minus 1. Simplify more, we have a sub 5 equals to a sub 1 times r raised to the 4th power. Next, a sub 5 is equals to 3,125, while a sub 1 is 5. Substitute all those values. We have 3,125 equals to 5 times r raised to the 4th power. Now, to solve for r, divide both sides by 5. We have 3,125 divided by 5 is equals to 625 is equals to r raised to the 4th power. Next, to solve for r only, take 4th root both sides. So, 4th root of 625 is equals to 4th root of r to the 4th. Now, 4th root of r to the 4th will give you r, while 4th root of 625 will give you 5. Therefore, our common ratio is equals to 5. Now, let us check using our calculator if this is correct. Okay, so we have 4th root. 4 is the index, so we have 6 to 5 and then equal sign, and the answer is 5. So we are correct. Let's continue. Now we know r is equals to 5, or the common ratio equals to 5. We are now ready to solve for the second, third, and fourth term. Second term, third term, and fourth term. N is equals to 2, n is equals to 3, n is equals to 4. Now, substitute all the given values. A sub 1 here is 5. Common ratio is also 5. So, a sub 2 equals to 5 times 5 raised to 1. Why 1? Because 2 minus 1 is 1. A sub 3 equals to 5. First term times 5. The common ratio raised to 2. 3 minus 1 is equals to 2. And same thing as to the fourth term. Now, simplify more. 5 times 5 raised to 1. 5 raised to 1 is 5. Times 5 is 25. Third term, 5 squared is 25. Times 5 is 125. Fourth term, 5 cubed is 125. Times 5 is 625. Therefore, the second term is 25. Next is 125, followed by 625, and 3,125. Now, another way to get those numbers, these three numbers, is just by multiplying this common ratio to our first term. Let's see. 5 times 5, the common ratio is 25. Again, multiply by 5, common ratio will give us 125. Times 5 again, common ratio will give us 625. Times 5 again will give us 3,125. So, therefore, this sequence is a geometric sequence having a common ratio of positive 5. Therefore, the three geometric means are 25, 125, and 625. And we're done. Next example. Find two geometric means between 6, and 18. Solution. Since we want to insert 2 geometric means, we are considering 4 terms in the sequence. We have 2 gaps between 6 and 18, so we have 1, 2, 3, 4 terms. So again, we need to solve for the common ratio because we're talking to geometric sequence in this subject. So we have a sub n equals to a sub 1 times r raised to n minus 1, the general formula for geometric sequence. Let n is equals to 4. Why 4? Because 1, 2, 3, 4, 4 terms. Substitute the 4, so n becomes 4, n becomes 4. Simplify more, a sub 4 equals to a sub 1 times r raised to 3. 4 minus 1 will give you 3. Next, a sub 4 is 18, a sub 1 is 6. Substitute those values, we have 18 equals to 6 times r cubed. To solve for r, divide both sides by 6. 18 divided by 6 will give you 3. 6r cubed divided by 6 is equals to r cubed. Next, to solve for r, take cube root both sides. We have cube root of 3 is equals to cube root of r cubed. Cube root of r cubed will give you r, while cube root of 3 is just cube root of 3. It is in its simplest form. So we have the common ratio, cube root of 3. Let's continue. Now we are now ready to solve for the second and the third term. Second term, n is equals to 2, and third term, 2 minus 1 and 3 minus 1. Next, simply substitute all the given values. This a sub 1 is 6. This r is cube root of 3. We have a sub 2 or the second term equals to 6, first term, times the quantity. Make sure once we substitute something or any number, positive or negative, please place those numbers inside a parenthesis. Okay? So 6 times cube root of 3 raised to 2 minus 1. R is cube root of 3. Simplify. 6 times cube root of 3 raised to 1. 2 minus 1 is raised to 1. Cube root of 3 raised to 1 will give you cube root of 3 times 6 is 6 cube root of 3. So we have the second term. Next, third term. Substitute, again r is cube root of 3 inside a parenthesis raised to 3 minus 1. So we have 6 times cube root of 3 squared. Cube root of 3 squared, or simply cube root of 3 times cube root of 3. And the answer is cube root of 9. Very good. So cube root of 9 times 6 will give you 6 cube root of 9. So the second term is 6 cube root of 3, or simply this first term times the common ratio. 6 times cube root of 3 is 6 cube root of 3. Again, multiply the common ratio. 6 cube root of 3 times the common ratio cube root of 3 will give you 6 cube root of 9. Now 6 cube root of 9 times against a cube root of 3 will give you 18. So let us check if this is equals to 18. 6 times cube root of 9, cube root of 9 times parenthesis cube root of 3, the common ratio. We expect that our answer must be 18. Cube root of 3. Cube root of 3. And then hit equal sign. And we have 18. So 18 is our fourth term. So meaning, this is absolutely a geometric sequence. Therefore, the two geometric means are 6 cube root of 3 and 6 cube root of 9.